Hello, everyone. I'm Elyar Pourrahimian, postdoctoral fellow from University of Alberta, and I'm presenting our work on behalf of Dr. Diana Salhab, Dr. Aminah, and Dr. Farook. So maybe the topic is a little bit confusing, like what is fuzzy chaos framework? I will try to do my best because this study is part of like a larger study that we've done before, proving the concept, the application of chaos theory in project management. So in this study, we are trying to understand how we can identify like interrelated factors, how they're impacting the productivity of the labor. And the effective management of labor productivity is important for us because it has a high degree of interdependency and it is somehow difficult to manage it, and dynamic and unpredictable conditions that can happen with the human being, like it has, because most of the studies that we've done is related to human-centric and labor-intensive projects, and high volume of unstructured and subjective data related to human beings regarding the cognitive load on the human being, regarding the problems that they have. Most of them are not captured in the data set. So, and the basic theory of chaos theory, which says like chaos starts with from the small changes in the conditions of the system. So, why traditional approaches might fall short on this area? Because traditional project management tools are somehow linear and deterministic, mostly like regarding the how productivity is changing in the project. And because of that, they fail to capture the dynamic and unpredictable nature of construction projects, and like construction environments are closed by many interacting variables, as I mentioned. So there is a need for adaptive tools to account for this complexity and change. Our methodology uh, includes four major steps. First is the factor shortlisting. What we identified, like we did a comprehensive study on the factors that are affecting the labor productivity, and we came up with 228 different factors under 8 different categories, which are the labor and crew related, task related, equipment and tools, supervisor related, location related, material and consumption, consumables, or safety, or the engineering and instructions. So under these factors, as you can see, we have different numbers of factors. First, we need to shortlist and make it suitable for our project, because in different projects, based on the complexity, some of the factor they have more importance compared to the others. The next step will be the fuzzy expert system, which we try to have the data-driven with expert-driven approach together. So in this stage, we use the expert analysis, which we use rule block because of the number of the factors we have, and we don't want to do lots of to get lots of input. We do rule block system, which each factors, as you can see, the sub factors are compared together, and then they create the top factor, which is the one of those 8 factors, and then we can compare those 8 factors to each other. The next step is like to do the pattern recognition, which we do in weekly basis, and it is automated. In this factor recognition, what we do is that simply we're using a run chart. The orange line in the middle is the median of the data set, and we detect the trend, the increasing trend or decreasing trend, and the shift, which are something like this. If every 5 or 6 consecutive data, which they're falling on one side of the median, it shows us a shift in the data set, and we need to consider and pay attention for that period of time. And we also identify the outliers of the data set, which we should exclude from our study. And the last step in our methodology is entropy analysis. But let me explain a little bit what we mean by entropy. Entropy basically is a fundamental concept in thermodynamics and information theory, and indicates the level of uncertainty and unpredictability in the system. As you can see, on the left side, we have a system with the high randomness and high entropy compared to the low randomness on the right side and low entropy. And entropy is like the measure of the disorder of the system. And like in project, basically, it talks about different states. For example, if you assume two different situations, that you know the first situation has the result of 50% chance of happening, and the other one has 80 and 20%. You know what are the results. So basically, if you calculate the entropy for the second one, will give you less entropy compared to the 50-50 chance. It shows that the randomness in the second system state is less. So we use this concept in the labor analysis, labor productivity analysis, and the formula that is being used for the entropy analysis is the Claude-Shannon entropy, which, as I mentioned, is the probability of different state happening, which is the formula, as I mentioned here. So what we do is that, like, using this methodology, we do two analysis. One is happening in the horizontal axis, which you can see the red one, which we are doing for each category of the factors. We are analyzing and we are understanding the situation of the system regarding that factor. And by doing the vertical analysis, which is our entropy calculation, we are merging all of these analyses together and we are understanding the randomness and uncertainty included in our system. So for the case study, we did this case study, which is $100 million industrial project. It has more than 400,000 labor hours. And the main scope was related to piping. And it includes like 280 personnel, like in the peak crew. And the method we use for our expert panel is like construction manager and only superintendent were included in our survey. And we did like analyze. I will show you two different distinct scenario for different weeks. The first scenario was like with high variability, which they had supply chain issues and spec changes. And in the second scenario, if they had more stable conditions, like the weather was perfect for the work, the crew was like all stable, no turnovers of the crew, and like the material was enough for the work of that week. As you can see, for the first scenario, when they did the fuzzy analysis, they give the different, we calculate different membership for being, for example, when safety says 0.5, 0.5 fair means that to the degree of 0.5, it's poor state, and for the degree of 0.5, it's in fair state. It's not crisp that it's poor or fair. And using this calculation, we calculate the entropy, which shows that 0.97 for the first scenario, which was as what it was expected, and 0.25 for the second scenario, which shows more stable state in the second scenario. So for the conclusion, our methodology integrates fuzzy logic for qualitative classification and applies entropy to quantify uncertainty in labor productivity. And practical benefits can be identified as it classifies factor as poor, fair, and good to reveal performance patterns, and high entropy shows the need for managerial attention for that specific category, and low entropy shows the stability which can maintain current practices. And the project management implication can be, we can say that it enables adaptive planning and risk allocation and resource allocation and risk mitigation, and support continuous monitoring and fast response to changes. For the limitation of this, it relies on accurate and complete input data and may be complex to apply without technical knowledge. And for the future direction, we can say what we are planning to do is to integrate with machine learning and real-time data, which is one of the aspects of these kind of frameworks, because they can somehow rely on subjective observations also. Thank you so much.